I work at ThoughtWorks, principal architect on the enterprise modernization platforms and cloud team. Started there a few months ago. And today we're going to talk about cloud native delivery patterns. Before we do, I'm going to tell you a little story. So this was not too long, it was 7 months ago. I was at a developer conference called DevOps Days in Birmingham. I was one of the speakers there. And a friend of mine works on the company behind the Flux product, or Flux open source project. Raise your hand if you've heard of Flux or you know what it is. Cool, all right, that's good. We'll talk about that in a minute. And he and I were just catching up, having a beer, talking about life and all that kind of stuff. And he works on a pretty large open source project. So if any of you have met like Mike Hardington downstairs, people will just, similar experience, come up to him randomly and start just talking. So this happens to my friend a lot too. And we're having a beer at the speaker dinner before the conference, and this guy just sits down in front of us, doesn't even look at me. He immediately is just like, Argo or Flux, which one's better? And I was kind of like, that was a little rude, but okay. And I kind of draw a parallel to that of like, what if I came up to you and said, Vim or Emacs? The answer is Vim. It kind of felt like that, but he calmly, took it in stride, and I had a nice graphic for you guys for learning Vim. He took it in stride and asked him some compensating questions, get some context and all that, and ended up giving him an answer. The answer, in my mind, kind of was, it depends. And the developer walked away a little happy, a little not happy, because he got the it depends answer. And the reason that too fast. The reason I wanted to tell you this story is we, as developers, tend to get very passionate about a lot of our tools. And one of the things that occurs with us is we get very emotional about those tools because we've made gambles and bets on specific technologies. So, for example, we decide we're going to use Golang over Rust or something like that, and it gives us a certain feeling or a certain draw to that because we've made those choices for our career, for how much money we make, people depend on us. We've made those choices for a reason. And so when somebody starts talking about a different tool, the one that you didn't pick, that first feeling you have is a feeling of maybe self-preservation, or maybe a little bit of even like anger, but it's not necessarily anger, it's just sort of a mix of like fear and self-preservation. And we have to sort of set aside that feeling and then think about it in terms of an open mind. So what I mean by that is when you approach a software problem with one of your clients or customers, you think about it in terms of what architecture do I need? What trade-offs do I need to consider? Well, when it comes to CI and CD tools, people tend to get a lot more passionate and involved in those tools. And it's like, oh, I've used Jenkins for 10 years and that's what I'm going to do, and that's worked for them. And what we fail to realize is a lot of these tools are also just software projects. They're software products. And so there are architectures behind these tools. So the point of the talk today is to talk to you about cloud native delivery space, the tools that are in that space, but more importantly, understand the patterns that those tools were built on top of so that you can make the right choice. So instead of just, I heard of this thing called GitOps and I'm going to start using it because it sounds cool, instead you're going to understand what that means and why it's important, and also why it's a bit of a buzzword, but then how you can kind of break that down and pick the right choice. So to get there, we're first going to talk about how we got to cloud native delivery in the first place. To do that, we need to look at just the traditional pipeline to understand the evolution of delivery platforms. Before cloud native, before Kubernetes, distributed computing, and all that kind of stuff, we had more of something that looked like this. Build, test, package, sign, deploy. Very synchronous type of process. You'd see these in Jenkins or some of the older systems as well. If one of these steps failed, the other ones would not continue. Singular, synchronous process. And what was also sort of important to realize is during times when these were extremely popular, there was only one deployment environment. You didn't have multiple production clusters, you probably had one in a lot of cases. So, and even if you didn't, you would have to then manage maybe multiple parallel synchronous pipelines, but that's what we have. Well, as times changed, things like Circle CI came out, Travis, and we started to componentize some of these steps. So today you can work with, say, Circle CI, and you can actually version and modify the different steps of your pipelines, publish those to your developers, and they can maybe take a subset of 3 of those. They don't need this one, and then this one, and package those together. Kind of like functional programming where you compose functions together. And these are versioned and signed and shipped to your company. Well, then along came Cloud Native, where we're targeting these multiple environments and Kubernetes or Mesos or whatever it is that you use. And all of a sudden, we had to deal with the fact that we're deploying to more than one environment in these cloud native spaces. And this is where things started to get pretty complicated. You no longer just had a single synchronous pipeline process deploying to one environment. You needed to get to maybe 2 production clusters. If you're a global company, you probably have environments in North America, Europe, Asia, and you're trying to make sure you deploy to all those different environments. Doing so with the traditional pipeline was a bit hairy, a bit complex. You were managing all kinds of different target environments and secrets and making sure that your delivery system was properly using the correct one and targeting the correct environment. So this was a problem that was growing and growing to the point where when Kubernetes hit the scene, another set of solutions also hit the scene. And these are cloud-native delivery platforms. The one I mentioned before, Flux. You have Argo, Spinnaker, Tecton. These are some of the commercial offerings of those. The Continuous Delivery Foundation is a partner of the Linux Foundation. They support some of these open source projects. These tools provide a cloud-native experience for delivering software to Kubernetes, to Docker Swarm, and some of those other tools. What they really are doing is they're providing an easy way to ship containers to your environments. And these tools came into being because of that complexity of deploying to multiple environments with containers. So I mentioned GitOps, and I want to talk to you a little bit about that because it's a bit of a buzzword. The term GitOps comes from a company called Weedworks originally. They're the company that created that, Flux. Like I said, I have a couple friends that work there. Great company, great tool. The term can be a bit misleading because it's used differently depending on who you ask. In fact, if you ask Weave, GitLab, Dynatrace, and Red Hat, you're going to get 4 completely different answers. The one thing that you're going to see that they all have in common when they answer this question is single source of truth. Now, why is that? Well, it's kind of in the name, Git. So the whole thing about GitOps is that your deployment configuration, if we jump back to this guy, for example, your deployment configuration for going to this environment and any of the other ones is stored in a Git repository. So you might say, deploy version 1 of my application to these 4 clusters, and that's expressed as code or YAML in Git. And you actually say U2 to cluster 1, like that kind of thing. So it's extremely declarative and extremely expressed, and it's also versioned through that Git history log. Well, there's actually an important architectural distinction that comes from that. When you think about the fact that I mentioned earlier, delivery tools are also software products. These are tools that were built with certain architectures in mind. Well, when you look at a software pipeline, if we go back to this guy, this is an event. When we decouple delivery systems from build systems, so like let's say we have a CI process, Jenkins, or whatever you want to use, and we pull this guy out from the rest of our process. When we decouple the build process from the deployment process, we have effectively just adopted event-driven architecture for our delivery system at that point. The tools that we have in this space, some of them are more focused on event-driven architecture than others. So for example, we'll take a look at Spinnaker a little bit. that there's an initial event to trigger a deployment cycle, and then everything else looks pretty normal. You have some deployment pipelines that go through that process. Whereas something like Argo, you're going to see a lot more event-driven architecture happening. But it's an important thing to realize that in the cloud-native space, most of the delivery tools in this space are focused on event-driven architectures. So, I want to touch on a couple of those. We're not going to talk about all of them. If you want to learn more about event-driven architecture, I would say go check out Martin Fowler's talk on YouTube. It's got like 500,000 views. But we're going to talk about these two. Oh, that's an error. That's supposed to say event notification, not the same thing there. So event sourcing and event notification. Right there. We're not going to talk about event carried state transfer and CQRS today. Those are much more niche patterns that are useful, but I would encourage you to go learn them, but don't do them today. So going back to that concept we talked about earlier, an event that triggers a pipeline essentially means that at the beginning of any delivery process in a cloud-native environment, it's event-driven or event-triggered. And we mentioned earlier event sourcing. So when I talked earlier about Git, GitOps, and all that kind of stuff, something that people don't realize is that they've been using event sourcing in their day-to-day life. I'm assuming most of you have used Git at some point. You are actually using event sourcing. Because what event sourcing really is it's a ledger or a summation of steps that leads to current state. So what I mean by that is the best way to describe event sourcing is if you lose your entire application. Like let's say your application crashes, all your microservices are down. If you can get back to the state that you were in from your log, that is an event sourcing implementation. So what I mean by that is if you were able to rebuild like all of these series of steps that occurred and in the order that they occurred to get back to your original state, that's event sourcing. To give you a better example, bank accounts. Bank accounts are not columns in a database. You wouldn't call your bank and say, I should have 10,000 in there, but it says 1,000. And they do a database lookup that says the column says 1,000. You're not going to be very happy with that answer. What they're going to do is they're going to walk through a series of transactions with you that lead up to the value that you're currently at. There is no static value in your bank account. It is actually a summation series, or it's a summation of steps that occur to get to the current state of that value. It's never a static value. Git is the same. Git is a series of transactions with the files that are stored in Git, and you can replay all those to receive the current state of Git. So when we think about the fact that our deployment system is being managed by something like this, it's actually more powerful than we initially realized. So this is the architecture of Flux, the tool that I mentioned earlier. We're not going to go too far into it, but I want to at least kind of highlight what's going on here. So inside of Kubernetes, we're going to have some controllers deployed by Flux. So a source controller, customized controller, and then these are Kubernetes specific resources. What's going on here is Flux, this controller, and this controller, they're applying applications or deploying them into your environment. And what they're doing is they're listening to this source controller. What this source controller is doing is it's subscribed to a repository in Git that controls the deployments to your clusters, to your different environments. So you can imagine that this is, say, a single production cluster in the US East or something, and it's subscribed to the repository that you have in Git that stores the configuration for that environment. It's polling that environment, that cluster repo, every minute. And so when you really think about it, Flux is actually just a client for an event sourcing database. It's cache. It's cache that is sitting in front of an event sourcing implementation. And so from that aspect, you really have a pure event sourcing implementation for your deployments. And one of the ramifications of that is whenever you want to make changes or deployments into your environment, your touch point is here. There's nowhere else. You go to Git and you make changes. That's how you deploy code. There's obviously some automation you could put around that, like say you have a process that deploys to dev, like say you have a new image or version that just got published. You might have an automated process that updates Git for you and pushes that out. But nonetheless, the touch point of the user experience is going through Git. Argo is another cloud-native delivery platform. These are the two competing products we talked about earlier. But they're not competing. In fact, these two projects work together all the time. And you'll notice that it looks way different, but there's a couple of similar things. There's a repository service. This repository service is keeping in sync with the Git repository. The main difference here is that you can interact with deployments for Argo. So let's say this is your different environments that you're deploying to. You can interact with Argo through a user interface, through a CLI, or through Git. So Argo takes it up the next step. They say, yes, we are using event sourcing as our backend, but we're also providing a more enhanced user experience with a user interface and a CLI and API around those. So it takes away from you get some benefits from having a pure event sourcing approach from Flux. For example, if you have a lot of really strict audit requirements or compliance requirements, the ability to make changes through the UI and push those out without updating Git through Argo could break some of those requirements. So those are some things to consider. If you have developers who really want that user interface, they want the button to click to deploy, that's a reason maybe to go with Argo. To give you sort of a better example of how those two tools are, I actually created this diagram for that previous conference to talk about a different pattern, but it actually is quite helpful. You're going to have two clusters subscribed to the configuration repo. But the reason I wanted to show you this is this configuration, we have a config repo subscribed to, two clusters subscribed to a config repo for staging, is that you could do this with Argo or Flux. It doesn't matter. It just really depends on the requirements of what you need. Now, to jump into, say, a different tool that isn't using GitOps but is considered a cloud-native delivery tool, we could talk about Spinnaker. Spinnaker is a much more, and I know that's a nightmare, we're not going to get into all that. There's a couple areas here we're going to talk about, and we're going to ignore the rest. Spinnaker is a much more traditional API-driven and also pipeline approach to cloud-native delivery. And instead of using Git as that backend or source of truth, they actually have a SQL database and S3. So some of the ramifications of choosing a tool like that for your cloud-native delivery is you now have to manage the database for backup and recovery. You now have to make sure you're properly managing S3, which has security requirements. Lots of CISOs are very touchy about S3 and making sure you configure it correctly. So there are some trade-offs there. That said, Spinnaker has a pretty powerful interface approach where if you have a lot of developers that are used to that pipeline experience, like say through Jenkins or something else, Spinnaker is going to give you that sort of step-by-step synchronous-looking deployment process, but you can actually subscribe it to multiple clusters. The difference is in that more traditional database API-driven deployment system, Spinnaker is pushing out to those clusters, whereas in the previous examples with the GitOps approach, those clusters are subscribing to their configuration and pulling it down. There are some security and networking considerations you have to think about in that scenario. When you are pulling down, you can actually lock down a lot of, if you think about opening, say, firewall holes or ports, it's much safer to be able to pull versus push in towards your environments. If you can lock down these clusters and say, I don't want to let anything talk to them except for HTTP traffic, you can do that. In the Spinnaker case, you can't because you have to open up Spinnaker to be able to communicate with these. So there's some considerations there if that's a requirement for your environment. So to sort of summarize, and there's a part two we're going to talk about in a minute. To summarize the tooling, GitOps focused tools, you can take a sort of purist approach which is really strong for environments where you have compliance requirements, security requirements, audit requirements. Auditors will love you if you use Flux, I'll tell you that right now. Developers that are used to having a UI for deploying are not going to like Flux very much. It's going to take time to get them to really appreciate that, but I've found that over time, developers that adopt a tool like that slowly are like, oh, I just go to make my tweak, like let's say I need 200 milli-CPU or 200 or 2 gigs of RAM instead of 1. They go straight to their config repo, make that change, Flux deploys it right away to that target environment, and it's within seconds. In that sort of hybrid approach, like we talked about with Argo, you're still getting the benefits of GitOps, where all of your source is based on Git, so you get the benefits of event sourcing. So if you lose all of your environments, you can bring them back up, register them with the clusters, and everything's as it was before. So you still get that benefit. But you also have the additional user experience things, such as a UI and CLI. Just the one trade-off there is you might lose some compliance and audit requirements from adopting something like that. So you have to consider that, or make sure you're logging those events separately, not inside of the event source database. You also have to consider eventual consistency in this scenario, although it's pretty performant. But if you think about the fact that you have, say, 10 clusters registered to a production environment that's a Git config repo, those clusters are going to synchronize themselves over time. If you're expecting those clusters to all be synchronized to the current production configuration at roughly the same moment, you're going to run into problems. But if these are distributed environments where they don't care about each other, it's not an issue. That's something you consider. And then as we get into the more traditional focused database API driven tools like Spinnaker, you have to manage a SQL database, you have to manage storage, so there's some things you have to consider there. But the point of all this was to show you, when people say, oh, well, I picked Argo because it's the best tool or it has the most GitHub stars, ask them why. Tell them, oh, well, I learned about event sourcing and I learned about the trade-offs between user interfaces versus having a pure, audit-focused deployment system. And as you get into more of those details, you might find that they need to use a different tool. So the next part is deployment patterns. And these are the patterns that these tools employ. And what's cool is in the cloud-native space, we have, I'm going to talk about 3 today, blue, green, canary, and A/B testing. All of these patterns are employed by these tools, Spinnaker, Argo, Flux, and all the other ones we had in the earlier slide. And these patterns are cloud-native focused patterns, but it doesn't really matter like which tool you use, but they're still going to be pretty common. So the first one is the blue-green pattern. So imagine in your environment you have version 1 of your service deployed, and you want to get version 2 out there. You're going to go ahead and get it deployed, but not send any traffic to it. You're going to wait for it to completely finish deploying, and maybe run some manual tests, smoke tests, if you will. You're then going to completely flip all your traffic over to V2. You're then going to go and shut down V1. That's blue-green in a nutshell. You might also hear some people say red-black as another name for the same thing. There's some slight differences between blue-green and red-black, depending on who you ask, but they're roughly the same. Our next pattern is the canary pattern. This is my personal favorite because it's the most automated approach. It does require a lot more instrumentation up front. We'll talk about that. So same scenario, you have V1 deployed to your environment. You're running 100% traffic to that service. And you're then going to route maybe 10% of your traffic to the new one after you have it deployed. Well, from this point, you're going to iteratively increase the amount of traffic that's going to now work maybe 50, 0. And that was aggressive. Usually you maybe go in increments of 2 to 10%. And you're running tests. You're running metrics tests. And so the way that most of those tools I showed you earlier work is they have a canary-based implementation where you could say, okay, I want to route incrementally 10% of traffic more to the new service every 30 seconds if you aren't seeing any HTTP 500s or 400s or 401s or what have you. If you start to see errors, stop scaling that traffic out. If those errors continue, that controller will route fully back to 100% V1. All the tools I talked about do this. They do usually require like a service mesh or sidecar type implementation that will allow you to get those metrics out of those services, but they all allow it. Our last the last one to talk about is A/B test. This is more of a manual approach. It's really useful for things like experimentation. So let's say, for example, you have a user in California and you have another user, or Canada, and you have another user in North America, and you have maybe a hypothesis about some of your users in Canada, or you have a hypothesis about some of them in North America. You could run a A/B test that says route all of my traffic from North America to V1, and then route the experimentation traffic to V2, or maybe everybody goes to V1 except for the users in Canada. You can figure this out through IP lookups or headers or whatever you want. This is more of a manual process where you're doing this and then collecting those metrics, pushing them to maybe a dashboard or a database or something, and then you're saying, okay, my experiment worked out, then you might go ahead and manually finish rolling that out to the rest of your users. The tools we mentioned before also allow for doing A/B testing. So that's pretty much what I had for today. To summarize, the strategies that we talked about before should help you be able to pick cloud native delivery tools. Patterns, strategies. The patterns we talked about at the start should help you pick the right cloud native delivery tool. You're looking at event-driven architectures such as event sourcing, event notifications, or you're looking at more traditional API-driven microservice, SQL-based cloud native delivery systems like Spinnaker. But understanding how the internals of those systems work will help you make a better decision. Realize, though, that all those tools are going to enable those strategies we talked about, like Blue, Green, and Canary, and AB. And so once you've picked the right tool, you can go and start adopting those best practice delivery methods with any of them. So there's sort of a benefit there. I think that the trade-offs you really need to think about when it comes to these tools are maintenance, like in the Spinnaker case, managing SQL databases and that kind of thing can be a pain, but there are vendors that offer this kind of thing for you. And user experience. Do you have developers that need that user interface, or do they not care? Maybe they don't. And, yeah, that's it. Any questions?
So when you do, so I work in a client where they have like two production and a non-production cluster.
Yeah.
So the non-production cluster basically has dev test and the staging, and the production is the production.
Yeah.
Now, when I have to use a system like Flux, would you recommend that I have to choose Flux?
I'll show you. Yeah. Back to here. So you're going to have Flux, like let's say this is your QA and this is your prod. You're going to have Flux deployed here, and you're going to have Flux deployed here, because what you're doing is you're deploying Flux to each of those and then bootstrapping it through this bootstrap repo, which then points to the different environments.
Yeah. So when you do that for the non-production repo, you would have, so the health controller, the customized controller and all that,
Yeah.
would essentially have the maximum, I mean, like, they would then be able to deploy across any.
Yes. You do in that scenario. I think Flux out of the box will be cross namespace, but you can also control it to be limited to specific namespaces as well. Same with Argo.
Okay. But you do not multiple instances of the.
Oh, not in the same cluster. No.
Okay.
I would just give it cross namespace access with the service account. Yeah.
So none of these. So I have some experience with Flux. That's going good, but I haven't tested Argo.
Yeah.
But pretty much all of them were the same.
Yeah.
But Argo can't put.
No, Argo is also going to be pull based. If you're using Argo CD, Argo does have a sub project called Argo Workflows that's much more like a job pipeline type tool that you could do like some custom push stuff. But I would maybe use Circle or something instead for that. Spinnaker is going to be the more push out based tool where it says I have a target cluster. Spinnaker is going to control pushing out. Spinnaker's, you saw the graph. It's a lot. I've used it in production. It's a good tool, but it takes a lot of learning. Question.
Do you mind going over the blue-green pattern?
Sure. Yeah. So we'll jump down here. So in the blue-green scenario, I actually have my colors backwards, but it could be any colors really, as long as there's just two. Doesn't matter. It could be yellow, black, or anyway. Those are just the common names. So you have a service deployed. Like let's say this is version 1 of Hello World or something, or Hello RESTful. You maybe have 3 replicas of that service currently running in parallel. So all 3 of these are receiving traffic. This is a load balancer. So what this is doing is this user comes in, load balancer is going to decide I want to send traffic to one of these, whichever one's under the least load. You then have version 2 of your Hello World. You go ahead and get that fully deployed and rolled out. And once you can see that it's fully deployed, this can be automated, by the way, like through a test that can say, oh, is it fully deployed? Yes. Then you go ahead and switch all of your traffic over to V2, and you start deprovisioning version 1. Some teams and companies choose to leave both active for a while, so that if you start seeing failures over here, you can flip back really quickly. But this is why I'm actually a huge fan of the Canary, because it's going to do all of that for you. It's just a little bit harder to get that running from the beginning, because you need to be able to read those errors. Like say you start sending traffic to V2 and you're getting a bunch of errors, you need to collect those errors in some sort of metric and then give that metric back to the deployment system, whether it's Flux or Argo or Spinnaker, so that it knows what to do with that.
Pattern. How do you manage that rolling back process if you're
in that case, you could write an automated script that would look up those metrics if you're collecting them, but in that case, a lot of people are just doing a manual switch back. Especially in what I've seen a lot in terms of my past experience is blue-green is used for infrastructure. So, like if we're rolling out a new production cluster, we'll deploy, say, we have currently like green prod 1 US East and Amazon or Google or something. And we'll then go ahead and deploy blue prod 1 East, register it with Flux, get all of the applications that are supposed to be there deployed, and then we'll do the switch to that brand new cluster environment. And if we start to see any issues, we'll flip back to that cluster environment. Inside of the cluster, we use the Canary process for all the individual services within it. I found that to be pretty effective because the manual makes sense when you're replacing entire environments. But Canary is super useful for like tiny microservice changes.
You still have the little guy.
Oh yeah, it was giving us trouble. So
Okay, we fixed that. So can you wear it now, please?
Oh sure.
I do clip. It should not go in the room anymore.
Yeah. Cool.
Thank you.
Just in time. Question?
Is this anti-pattern to combine some of these patterns? So
Nope.
I want the benefits of Canary, but I want to only deploy B to say my Canada audience or whatever. Is that just too complex?
No, not at all. You could totally do that. In fact, at my last company, we even combined deployment tools. Like we used both Argo and Flux, and Flux was handling a lot of the blue-green rollouts, and Argo was handling a lot of the Canary deployments. And so yeah, we used both in parallel.
It's a lot messier.
Yeah, it's more to handle up front, but you can totally combine them. And I actually seen that before. Like you'll see a lot of places where they use Canary as their primary rollout strategy, but then use that A/B process when they want to test a hypothesis. As long as you don't hook that A/B test up to the current main Canary deployment, like say you just configure another deployment chart or YAML or something, then they won't conflict. Yeah. Just give it a different name in the load balancer, something like that. Question?
In terms of what metrics you're looking for the errors in the Canary deployment, Are you able to ever reuse those, or is it kind of like if you have that overhead every single time?
Reuse in what sense? What do you mean?
Like if you're saying like, okay, if we start seeing these errors, then we want to roll back to these one.
Yeah.
Like, can you reuse what specific metrics you're looking for? Like, does that ever happen?
Yeah, you can. So like you're saying, if I rolled out V2 and it failed the first time based on 404s, then I might write an additional canary test that says if you see this percentage of 404s ramping up, then go ahead and fail that canary faster. Yeah, you could totally do that.
Okay. Yeah, I guess I was thinking at like you said it was a lot of overhead to be the canary, and that's because of the metrics, or why? Overhead's a bit of a weird word for that. So I guess the reason I say overhead is because to do canarying, that's weird. To do canarying, most places will use a service mesh to do that. So you're going to need a sidecar inside of your deployment. So like if you see the little grid, like pretend this is one pod in Kubernetes, you might have the primary application and then a sidecar that is reading all the network traffic coming in and out of that pod, and then saving it to like a service mesh metrics database or a Prometheus database or something. So I guess that would be the overhead, is instrumenting that collection of that metric and putting it somewhere. And then there's some effort involved to get that set up and working correctly. You've got to learn about Istio and learn about Prometheus and setting all those tools up. It's worth it. Okay, and so for your next canary deploy, can you reuse that?
Oh yeah, because
That's kind of a one-time.
because you're pushing all that data to a time series database. So at that point, you actually have a historical collection of all those rollouts over time. Maybe that'd be another good talk. Yeah. Yeah, Prometheus is one of the best. Any other questions?
I have one more.
Oh, yeah. Go ahead.
Can you give an example of like, if I were to pick Argo over Flux, like why would I need that UI or CLI ability?
Yeah, in that scenario, I would go straight to my developers and let them use Argo, let them use Flux, and tell them what feels better, what feels more natural to them. What I found is that at older companies that have been doing software development for a long time, like insurance, finance, fintech, some of those, they tend to prefer Argo because they're used to having those enterprise tools with the user interface and the single sign-on and all that kind of stuff. You'll find those mid-size or newer companies who have already been using Git for everything since day one tend to really like Flux. There's an interesting trade-off there, though. Those older companies I talked about are usually very obsessed with audit and compliance, and so Flux is very exciting to them for that perspective. So Argo kind of meets them in the middle there, where it gives them that audit control of the deployments that have been rolled out, because Argo is still reading Git repositories, but gives developers that user interface that they want, because they're used to that at that company. So. Yeah.
No question. I'm very new to this, so I was able to follow stuff.
Thank you.
But so who at the company, like what role would like looking at patterns and making this decision on what's the best?
Yeah, that's a good question, actually. So traditionally speaking, it'd be like a DevOps team or a platform team or something like that. But my team at ThoughtWorks, we really pushed back on that and said, like, DevOps engineer is not necessarily a job title. DevOps should be everybody's responsibility. So you'll often find at companies now that your architects or your lead developers or your senior engineers are the ones that care about this kind of thing, because we're starting to see a shift where developers are responsible for their own deployments. You look at Netflix, for example. Every microservice in the Netflix orchestrator clusters is actually deployed to production by the team that wrote it. And a lot of other companies are starting to do that same thing. So it depends completely. It depends completely on the company, but you'll see that quite often that the development team can maybe choose their own. And these tools are so lightweight that actually
that was why we had Flux and Argo and Spinnaker running in the same environment at my last company, because we let the developers pick which one they wanted to use. I think I'm being kicked out. All right. All right. Thank you all.